Alright, first we're going to go over the differences in how particles move in solids, liquids, and gas. So this is point number 13, how particles move in solids, liquids, and in gas. So you can go ahead and take out your notebook and open up to point number 13. Before we start, just visualize each of the three. You got air for gas, the air that you're breathing right now. Liquid, we got water. And for solids, you can use a desk or a TV or maybe a computer, whatever you're currently watching this on. So you have your solids, liquids, and gas. Now just think about if I had never taught you what you would assume that particles act like in these. Wouldn't you assume that in a desk or a TV that the particles are very tight and close together and connected, just like the TV in front of you? TV is not floating away from itself. Then again, if you think about liquids, particles in a liquid, they seem to be a little bit more free. I mean, they can kind of move around. They don't necessarily have a shape, right? There's whatever shape they're in. The solid is the bottle, but the liquid is whatever shape I put it in. So liquid seems to be a little bit more free. And then gas. Obviously, gas is the most free out of all of them. Now think about just the air around you. I can blow the air, and gas is the most free out of the three. So let's start at the beginning here. Gas is the most free. Liquid is somewhat free, and solids are confined. We'll start at the top. Because gas is the most free, it's also the fastest. Now, since it's so fast, it overcomes nearly all of the attraction it has to one another. All of these particles in here, they're moving so fast that they don't have to worry about being so close to one another because of how fast they're moving. That overcomes the attraction they have for one another, if you can understand that. Because they overcome the attraction for one another, and because they're so fast, they move at such high speeds, they're a lot further apart. Think about the air around you, the air around me. The particles in this air are so far apart from one another. They don't necessarily have to be really close to one another. Secondly, we have liquids. Now, particles in a liquid are somewhat free. Like we said, the water in this bottle takes whatever shape I put the water in. These particles in water, they don't move as fast as gas, and they're not as slow as solids. So because I just put medium here, they move at somewhat of a medium speed. They're able to overcome some of the attraction between them. Not all of the attraction. If they were able to overcome all of the attraction, the water would just be floating away from each other. But water doesn't do that, does it? No. It pretty much stays somewhat connected. Now, these particles, they're sliding and tumbling over one another. So unlike particles in gas that rarely ever interact with one another, and unlike particles in solids, which are so close to one another, always interacting, these particles are somewhat together. They're sliding and tumbling over one another. These hardly ever see each other except for when they collide. These are sliding and tumbling around each other, but they're a little bit more loose than solids, which are combined. So you got solids, which are confined to itself. Then you have liquids, which are tumbling and moving around each other, a little bit more free. And then you have gases, which are spread out far apart and kind of look like one of those rave dancers. They are a lot more further apart from one another. So again, with these liquids sliding and tumbling over one another, and because of that, they're a little bit closer than the gases. They're not as far apart as gas, but they are somewhat close to each other, and they do have some room. So it's kind of like the medium in between solids and gases when it comes to how close they are to one another. Now last we have solids. TV, desk, computer, whatever you want to visualize is fine. These are confined. Like we said earlier, a computer doesn't just float away from itself. particles in a solid move very slowly. Because of this, they don't overcome any of the attraction with one another. Instead of moving, they just vibrate back and forth. Now these vibrating solids, they vibrate in the same place and they're very close. You see here, these particles are very, very close to one another. And there you have it. Those are how particles move in solids, liquids, and gas. So you do need to know the difference between the three. And since I already gave you a test, and this is kind of your makeup, your last chance to get this for this chapter is going to be Monday. So try to remember it for Monday. Just remember, though, that my tests pile up on one another, so I'll probably ask you this again the following test in case you don't get it now.